Last time we talked about this 4 bullet point. If I have a sequence AN converts to A and BN converts to B, this 4 sentence is true. And with that proof, how do we find this? Well, we find this by writing it as a product. We have 2 terms. Now we can distribute it into these 2 terms. Why? Again, understanding why this is true is very important. It's because I have a first sequence AN, second sequence BN. So I'm doing this exactly the same thing here. And each of this limit is 0. So I have 0. What about this? This thing is a fraction. I can still distribute it. Why? Well, f divided by g is the same as f times what? 1 over g, right? Then this is my A. This is my B. Then I can use this, right? So you may think that, who the heck write this? There's a deep meaning inside. Because if I write something like this, now I can call AN and BN. So every mathematical operation has a meaning. If you understand all this meaning, you fully understand everything. If you don't understand one of them, that means in the future, when you see similar question, you get stuck. Now, this is what I talked last time, and I realized I didn't talk about one important thing. Actually, I didn't prove that if limit of a sequence go to L, then I take a square root, it converts to square root L. We didn't know. You cannot say, oh, I know this from high school. No, you need to prove it. So we are assuming if this is true, and of course, we assume everybody is larger than 0, otherwise we cannot take square root, right? So I'm saying if I have this box, it implies I have this box. This actually means what? I have a square root, it doesn't matter, my limit can go inside. So I have this box gives me this big chunk of sentence. My goal is to prove this box, this big chunk of sentence. What I'm going to do is using this big chunk of sentence, somehow give me this big chunk of sentence. That's the idea. Because of this, so I have the following. Let's recap. For any challenge from you, I always have a cutting point. Any n after n, that means the sequence after this cutting point, all the sequence are close. Then the gap you give me. The gap is the challenge given by you because you disagree with me. And also because you are saying they are not the same. So gap is not 0. If gap is 0, you agree with me. So I have this. So what I need to do is this. To avoid confusion, I change the symbol. Not epsilon. This is nu. Greek letter called NU. Okay. It's not V. This is not V. Okay. This is the nu. Okay. And then I also don't want to confuse the symbol. So this is N. Now I'm using M. Okay, I'm using M. So basically, these 2 sentences are the same sentence. The only thing that's different is I have a sequence. Now there's a square root here, and my limit have a square root. And of course, I assume A and L are larger than 0. Otherwise, square root complex number. No. So I want to show this, right? So what I'm going to do, I'm just trying to change this guy to look like this. That's it. Then how I'm going to do? This is what I have. What I want to do. Now I multiply something plus divide by itself. Why I'm doing this? Because I can cancel out the square root. So now I have this term. And now I have a fraction. I can split the fraction, and because I have absolute value, so I have this. Notice that I have a sign like this. Here's the funny thing. Because I have A larger than 0, so I have this, right? Just let you know, in exam, I'm not going to ask you this kind of question. This is what the math major need to do, but this part is actually what math major do, and they have this kind of skill is to, how do you go from this box to this box, is to, you make an argument that this will imply this. I just show you this kind of thing. I'm not going to test you this. So I'm saying, if this guy is larger than 0, then division of this guy is smaller than 0, right? And L is what? L is just a number. So I can take it like this. So now I have something that looks like this, okay? What is this thing? This thing is saying that AN minus L, by this big box, I have this smaller than epsilon. So now I have this epsilon. So that means what? I just need to change this whole thing. I rename it as nu, done. So therefore, this implies this. This whole example means that if I have a sequence AN, go to a limit, I call it L. If I put a square root here, it also converts to here. Later, I will tell you, same thing. If I put a log here, it's the same. I put a log. If I put a cosine here, it's the same. I put a cosine. You do the same kind of trick. The detail is exactly how you proceed inside this box. I'm not going to test you this in exam. So with this, then you can get this one, and same here. And then here's an example. If limit of AN is L, of course L larger than 0, otherwise I cannot take log, okay? Then if I have log of my sequence, it will be just log. So this means what? This, to prove this, means you can swap these 2 guys. You can put this here or put this here. The meaning behind this example is that you can now swap this. Before you prove this, you cannot say, I know this is true because of high school textbook. No, you need to prove it.